Oh, here we are. I've got it already. This is part of the Odyssey, the Iliad and Odyssey by Homer. He was called Polyphemus. And of course the story is here that the sailors become terrified because they're being chased by these grotesque figures.
Once upon a time, in a land far, far away, lived a creature many feared, a grotesque giant with one eye and a single tooth. His name was Cyclops. The ancients had no explanation for their existence, but perhaps there is one.
Life was really brutal, it was quite short, it was full of unknown diseases, anything like that, anything that's going to impact on your life. Then ultimately, to be able to understand it in a pre-scientific age, you need to be able to tell stories about that. And by telling the stories, you make these things less unknown and less fearful, and ultimately you bring them under your control by storytelling and mythology. In one sense, mythology actually humanises the unknown and the natural world.
So can this story about a mythical one-eyed creature really be true? Well, scientists today believe they can explain this phenomenon. The answer lies in our genes. I remember when I was training in genetics, my professor said to me one day, you know, mermaids are real, cyclops are real. And I was fascinated because I thought they were just myths and legends. But gradually during my training and my experience as a clinical genetics doctor, I've realized that he was right. Myths about cyclops always depict them as giants, but real cyclops that are born are tiny babies. How then do we get from a baby to a giant?
So in the Greek period, the skulls of dwarf elephants, probably about the same size today as a small cow, would have been found by Greek people living on the Greek islands around which the Cyclops myth was based. We're not sure, but that may have well also have been the case in the Paleolithic era, so going back millions of years. A dwarf elephant skull, dating back to prehistory, the skull would have been about 1.5 to 2 times the size of a human skull, but instead of having 2 eye sockets like a regular human skull, it would have just had one big socket, as we know, for the trunk, but they would have thought it was for one large eye. So from that, they logically extrapolated that giants were living in these places, giants with just the one eye. I think people would be very surprised that there are still, on the rare occasion, children and fetuses and children even being born that exhibit cyclopia. I think people would see them as very much a product of a much earlier period in time, maybe something that one might see in a museum in a glass jar.
In search for evidence of a real cyclops, our journey took us to Amsterdam to meet Dr. Laurens de Rooij, curator of the Vrolijk Museum at the Medical University. The museum exhibits human specimens with congenital malformations, including cyclopia, going back to the 1800s.
So here we have our collection of cyclops, or holoprosencephaly specimens. We have about 9 of them here, and you see a variety of the malformation. So there is, in this case, it's less severe than in the case over there. But it's part of this whole spectrum of malformations. One of the most severe cases of cyclopy also to me really resembles the cyclops in Greek mythology, because the way it looks. And interesting about this specimen is that it's from the original Vrolijk collection, so it's from 1832 or 1836. And Vrolijk actually dissected the specimen, especially the head. He took out the skull and he put that separately, he added it separately to his collection.
But how could the human body go so wrong? What is it that's responsible for such a dramatic malformation?
Well, we know after many years of research that we've got a gene now called sonic hedgehog for holoprosencephaly. And there are several genes involved now, and in that pathway that regulates the midline structure formation.
Professor Nigel Brown at St George's University is an expert in the study of the sonic hedgehog gene and has done many years of research into understanding its role in human development.
Human mutations that affect the function of sonic hedgehog. Some of these mutations have a very subtle effect, and so a subtle effect on the signal and therefore a mild effect on embryonic development. Some of these mutations completely knock out the function of sonic hedgehog. The mutations that completely remove sonic hedgehog, those produce cyclopia. Cyclopia is extremely rare, always has been very rare, particularly now that prenatal diagnosis is able to detect many abnormalities during pregnancy. It's now very, very uncommon for a baby with cyclopia to be born. The only animals that would have been studied systematically in recent studies would be in models in the mouse. By making variations in sonic hedgehog and other associated genes to look at the effect of those changes in embryonic development. And in those studies, very much the same spectrum as is seen in human holoprosencephaly can be recreated in the mouse with similar genetic variations. So this is a mouse embryo. This is the head end of the embryo, although most of the head has been removed, and here's running around the body and the tail portion of the embryo. And these little areas sticking out here are the developing limbs, so front legs and hind legs of the mouse. And the purple areas are areas where the cells are producing this important signal, SHH, sonic hedgehog. If I tip the embryo up, you can see a dark section right in the middle of the head of the embryo as well as the tail. So all mammals, humans included, express sonic hedgehog in exactly the same way across the embryos of all species.
Studies have shown that cyclopia occurs in about 1 in every 13,000 live births, but it may be as common as 1 in 2,500 pregnancies. However, the vast majority never continue to term because they result in an early miscarriage.
The most severe forms, they're always lethal, but because they can be variable degrees of severity, you do see people born with eyes that are too close together compared to the normal people, or with a single central tooth, or with midline defects, or sometimes genital anomalies with a tooth anomaly. They are very rare in their own right, and we must differentiate between how common they are in the context of being born, or how common they are in the womb. Because with modern technology, with modern use of imaging, we're now able to pick up abnormalities in the womb far, far quicker than we were before. I mean, I remember when I started medical school, it was difficult to even tell there were twins, let alone now where we can count the fingers on the hand, we can see sometimes a cleft lip, and of course we can look at the formation of the brain.
When it comes to the development of the fetus, how early does separation of the brain actually occur?
We have to go back to a stage at about just over 2 weeks of embryonic age, when the embryo is a very simple disc of tissue. Is that this, which is coloured blue in this reconstruction, this is all the developing nervous tissue, the brain and part of the eye. And it's going to receive a signal from underneath it and creates a midline in the rest of the embryo, separating out then 2 separate fields that are going to be separate eyes, separate cerebral hemispheres, separate areas of the face as well. And if you imagine that in cyclopia, all of this portion of both the brain and the head and the nose is almost all missing in a cyclopic embryo, that's a big change in structure. It's because the process, which normally would divide the initial area that can develop into eyes and brain, the process that divides that down the middle to create the left and right hand sides has failed. So it's not a fusion of two things into one, it's the opposite. It's the non-separation of one area into two.
It appears that separation of the brain is not the only role for Sonic Hedgehog. During early development, it is also important for correct hand and foot formation.
Abnormalities in Sonic can cause abnormalities in the digits and even in the number of digits. There is another rare and quite dramatic defect called serenomelia, in which embryos develop essentially with a single leg, although much less is understood about the embryonic origins of serenomelia than of cyclopia. But one possibility, and it's a strong possibility, is that again midline signaling involving Sonic Hedgehog and other proteins is important in the development of two limbs rather than one.
This knowledge seems to provide an explanation for the myth of mermaids.
And there's a whole legend surrounding mermaids and mermen indeed, and almost certainly those are all related to this midline serenomelia defect.
So if stories of cyclops and mermaids have connections to reality, then maybe other mythical creatures also have their origins in truth. Some say elves are real. Perhaps Rumpelstiltskin really did age before his time. But these are stories for another day.